Hello, today I want to show you about the shelter password. So before I explain to you about this topic, I want to explain first about process that when we log in to a website and how the website save our user data. So usually when you log into a website, it will be asked to you about the user or email. For example, email, example, and then you type the password here, example 123. Here's the password is 123, and then you click login. Yeah, this is the example. You see here, this is just a front end. But okay, now when you click this login, usually your password, for example, the 123, your password is 123. This 123 will be hashed. It will be encoded to this or hashed to this. So it will be resulted to this random string, and this random string that will be checked in the website. So in the database of the website, okay, let's get to the whiteboard. Usually here, okay, usually the table will be here, and the user, for example, okay, example, and you will be thinking that the password in the database, since the password that in our example is 123, so in the database will be saved as 123. No, it's not saved as 123. Instead, it's saved as here, as this random string. So you may be asked what the meaning of this, what the use of the database that save the form of this hashed form. So the answer is, so when for example, a hacker or cracker breach the database, so they will be get the user and password. They will be get the password in the form of in the hashed form, not the real password. So if so, when the user, for example, this random string, the hashed form. So if the hacker get this user and hashed password, when the hacker want to log in here, he can, because because it's in the hashed form. You can see here, but yeah, this actually this the SHA256. Yeah, this hashed is a one-way function, and actually there's no way to the inverse the function, so we can get from this random string we just inverse the function of this and get this. No, there's no way to do that. Only way is to save this in the dictionary. So for example, a string AAA here. If the hacker want to, for example, if the hacker want to know what the meaning of this, usually they will be the website, or maybe they have a database for this hash. So usually the process is like this, and when I click the decrypt in this website will be searched in his database about the real form of this. Let's check. And as you can see here, we get 123 in the in this database, the MD5. Now this is a problem, right? So that's why the salted password in rescue. Okay, now let's go to the code. So here, this is the implementation in Golang. So here I have a generate salt and has password. So here the process. Okay, now first example, for example, let's get the password as 123. Then after that, we will hash the password together with the salt. This is the process to get the salt. What is the salt? The salt is actually just a random string. You can see here, this is the process to generate a random string. Okay, so this is just a simply random string. So so after this, we hash the password. And the process is like this. Here we just concat the password and the salt. And then after that, we hash that. Then after that, encode that and save that to the database. Let's run this. Okay, here for example 123, and let's just run this. Okay, here this is the hashed port because since the salt is a random string, so we run this once again, it will be generated another random string. So it will be not. You see here, it's always different. And let's see what happen if we just using without salt. As you can see here, this is the form of the this is the form of the hashed that is without salt. And in here you can see here, we in this setting we just simply concat the string. Actually we can just like in that we do it like this, and we concat that, so it will be like this. Actually we can get it to like this, alt password, or maybe if you want to be more advanced, you can do it like this. This is the first word, and then after that the first word of salt, and then after that the three is the password, and then after that here. So it you know so it's whatever we want. And that's why when usually when you do a salted password, the table in the database will be like this: salt, password, and salt. There will be a three column. And in another setting, the salt here, to be more secure, it not saved in the same database as user and password. Save it in another device. So it will be more. So when the hacker or cracker breach the database, usually because he got not the salt. And yeah, another way to secure the database is doing a case scratching like this. This is the code. So case scratching, case stretching is just like, the blockchain. Yeah, the blockchain is doing the hash many times, right? So in here, usually when we doing the hash, we just doing it one time, right? So here password salt, we doing a hash, so we will get the hash form one. But in the cache scratching or in the setting of the PBKDF2, we will be doing hash many times. So from hash form, we will be hashed list, so we will get the hash form 2 and then hash it again, hash form 3 and etc. Hash form n. And in this code, I'm doing the hash it in 100,000. And what the meaning of this and what use this for? This is to make the brute force to be more expensive. So when hacker using the brute force method to crack the password, or when he get the solve, it will be more time consuming. Because here we must doing the we must doing the hash anytime, and as you can see here, the hacker or cracker will not know how many time that it need to hash. Yeah, this is just to make it more secure. Actually, I still not test this code, but let's test this. But yeah, you get the point. So I think that's all. Thank you for watching. Bye.